Hello everyone. On this video we will be going over sigma notation, properties, and formulas. Alright, so starting off we're going to explain exactly what a sigma notation is. And you've probably seen it tons of times before, but the sigma notation is just that notation there. Or sometimes you may see it drawn like that. That's your sigma notation. Let me focus that a little bit. There we go. Okay, so now let's get into the idea of how you would use the sigma notation mathematically. And it's not too bad. So the sum of n number of terms, and that n can vary. So let's say your terms are a number 1, a sub 2, a sub 3, and it goes all the way to a sub n. Okay, so writing that in sigma notation means they would be written as the sum of I equals 1 to n of a sub I. Because you see here that 1 is going up 1, it's going from 1 to 2 to 3 to 4 to 5 all the way to n. So we're starting at 1 and we're going all the way up to n, and that I is going to change with each one. So if we replace the I with 1, we'll get our a sub 1. And if we replace that I with 2 and add it, we have a sub 2. If we replace that I with 3 and add it, we have a sub 3. If we replace that I with 4 and add it, we have a sub 4. And that keeps on going all the way until we reach our upper bound, which is replacing the I with n. Alright, so now let's look at the parts of our sigma problem, or you can say your summation notation. Okay, so I is the index of the summation. Okay, now that can change. That could be an n, that can be an m, that could be a j, it could be literally any variable. But in this case, it's an I, so that's why it's the index of our summation. Okay, now your a sub I, or whatever expression happens to be there, is your ith term of the summation. Okay, that just means whatever expression you're going to be changing that I for. That's your ith term of the summation. Okay, now in this case, your 1 is your lower bound. And again, that value can change. You can start at 1. You may have some where you may start at 5. You may have some where you start at 20 and go to whatever your upper bound is. And that n is your upper bound. All right. So if you are still writing, feel free to press pause, but we're going to do a few examples of your summation and how to apply it. Okay, so let's say, for example, you have the sum from I equals 1 to 6 of I. What if you wanted to solve that one? Okay. Now in this case, you're going to start at 1. So let me go ahead and just rewrite the problem. I equals 1 to 6 of I. Okay, so you're going to take your if term and you're going to replace the I with 1. Remember, that's your lower bound, so you're just going to replace it with 1. Okay, now you're going to move up one whole number and replace that I with 2 and add it. You're going to move up another whole number and replace that I with 3. Okay. Then you're going to move up another whole number, replace that I with 4. You're going to move up another whole number, replace that I with 5. Then you're going to move up another whole number, replace that I with 6. Okay, and there you're going to know you're supposed to stop because your 6 is your upper bound. So you're going to start at 1 and stop at 6. Okay, so that's how you would write out the, I guess you could say, the expanded version of your sigma notation or your summation. Okay, so we're in that problem there. All right, let's move on up to another example. Okay, let's say we have the summation from I equals 0 to 5 of I plus 1. All right, so once again, I'm going to go ahead and just rewrite the problem. I equals 0 to 5. About to write. Well, you could write 1 plus I, but I'd rather keep it I plus 1. Keep it the same. Okay, now this one is your if term, the I plus 1. So what you're going to do is you're going to replace the I with 0. So that's 0 plus 1. So you're going to move up one whole number. So that will be replacing the I with 1. So that's plus 1 plus 1. Okay. Then you're going to move up another number and replace the I with 2. Plus 2 plus 1. Then you're going to move up another whole number. Plus 3 plus 1. You're going to move up another whole number. Plus 4 plus 1. Then you're going to move up another whole number plus 5 plus 1. Okay, so remember here, you replace the I. So this used to be the I. That was the I. That was the I. That was the I. That was the I. And that was the I. Okay, so replacing the I, we just went ahead and added them all together. Okay, so you see 0 plus 1 is just 1. Plus 1 plus 1, which is 2. Plus 2 plus 1, which is 3. Plus 3 plus 1, which is 4. Plus 4 plus 1, which is 5. Plus 5 plus 1, which is 6. And if you add them all together, you get 21. Same with up here, of course. You add them together, you get 21. All right. So let's move on to our next example. Okay, so let's say you want to find the sum from j equals 3 to 7 of j squared. All right, so what I want you to do is I want you to press pause and try to solve this one on your own. All Alright, so I'm going to go ahead and rewrite the initial problem. So we have j equals 3 to 7. And we make that a little bit bigger of j squared. Okay. So once again, we're going to start at our lower bound. So we're going to replace the j with a 3. So instead of j squared, we're going to have 3 squared. Okay, so we're going to move up 1 and then add it. So plus, so we have 3 squared plus, we're going to move up 1, 4 squared. And we're going to move up 1 more. Remember, we're just working with that j squared. So we're going to have plus 5 squared. Then moving up 1 more, plus 6 squared. Then moving up 1 more, we have plus 7 squared. Okay, so remember, we started at 3, and we just replaced the j with each number going up, and we stop at our upper bound. So we have 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. So really this is just j squared plus j squared plus j squared plus j squared plus j squared, but the j is going up 1 each time. And that is actually 135 if you add them together. I'm more concerned with making sure you know the setup than I am the final answer. Although some questions will ask for the final answer, I'm more concerned with you being able to set this up than anything else right now. Okay, I'm pretty sure once you have it properly set up, you should be able to figure out the final answer. But if you don't have it properly set up, then the final answer is going to come out wrong. So that's why I want you to focus on that for now. All right, so let's do one more example. So what if we want to know the sum from k equals 1 to n of 1 over n k squared plus 1. All right, so I'll purposely use this one with 2 variables. Okay, so I'm just going to go ahead and rewrite it from k equals 1 to n of 1 over n k squared plus 1. Okay, now this, remember that's your, you can't call it your if term anymore because we're not using the I. So that's your, pretty much you can call it your expression here with k as your k to the if k kth power, I guess you can call it that, but you get the idea. You're using k as your index in this one. Okay, so what we're going to do is we're going to rewrite this, but we're going to replace k with 1. So you have 1 over n 1 squared plus 1. Okay, now we're going to go up 1, so that's plus 1 over n 2 squared plus 1. Because remember, we're just replacing the k. 2 squared plus 1. So that's plus 1 over n 3 squared plus 1. And you're just going to keep replacing the k and adding them together until you reach your upper bound of n. Uh-oh, forgot my room for my 1 over n. So once you reach your upper bound of n, that's 1 over n squared plus 1. Okay. Now, since you have 1 over n for each of those terms, you can actually factor that out. And I waited till this point to point that out because you could have factored your 1 over n out up here. So it would have just been 1 over n times this summation. But you can do it afterwards also. That's why I waited to the end to show you can do it either before or after. That's 1 over n times 1 squared plus 1 plus, and you already factored out the 1 over n, so you have 2 squared plus 1 plus 3 squared plus 1 plus, and it keeps on going to n squared plus 1. Okay, so that will give us 1 over n. 1 squared is 1. 1 plus 1 is 2. Well, you don't really need the parentheses here. Plus 2 squared is 4. 4 plus 1 is 5. Plus 3 squared is 9. 9 plus 1 is 10. And you will keep up that entire pattern for whatever value of n that you plug in. Okay, so if you want to know the next 30 terms, you just plug in n squared plus 30, and it keeps on going and going and going. All right. So if you are still writing, feel free to press pause. But now we're going to go into some summation formulas. Okay, so summation formulas. Okay, now there are a ton of summation formulas. We're only going to cover 4 of the, I guess you could say, basic ones, because they get really complicated the higher you get. Okay, but we're going to cover just like the basic ones for now. Okay, so the first one, say the sum from I equals 1 to n of a constant, that constant we'll just call c, equals c times whatever your n is. Okay, now second formula, you have the sum from I equals 1 to n of I. Now you see how before we got the I and we had to add it and add it and add it and add it and add it. You don't have to do that. So if you have from I equals 1 to 30, you don't want to have to go, okay, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. You don't have to do that anymore. That's going to equal n times n plus 1 over 2. All right, so your third, we have the sum from I equals 1 to n of I squared. Remember on our example, we had j squared on that example, and we had to add them all together. You don't have to do that, because if you have from I equals 1 to 30, you don't want to have to write 1 squared plus 2 squared plus 3 squared. You don't have to do that anymore. You just have n times n plus 1 over 2n plus 1 all over 6. And your fourth summation formula, you have your sum from I equals 1 to n of I to the third power is equal to n squared times n plus 1 squared all over 4. Okay. And again, when you get to I to the fourth power, it gets a little bit lengthy and complicated, so we're not really going to cover that one. But quick Google search if you're just curious, can show you the formula for that one. All right, so what we're going to go ahead and do now is we're going to prove 1 and 2, because the third one is a little bit lengthy and I don't want to bore you with that one. So we're just going to prove the first 2, so you can see how the proofs are done. Okay, so proof of the first one. Okay, so let's say if we have the sum from I equals 1 to n of c. Alright, now if you wanted to, you don't have to write it this way. That's the same as saying the sum from I equals 1 to n of a constant times x of I to the 0 power. Remember, anything raised to the 0 power is just 1. So x of I to the 0 power is just 1. Okay, so if you replace the I with 1, that's just c times 1 to the 0 power, which is 1 to the 0 power is just 1. So that's just c. Plus, if you go up 1, 1 times 2 to the 0 power. 2 to the 0 power is just 1. So c times 1 is just c. Replacing it with 3, you have 3 to the 0 power, which is just 1. So c times 1 is just c. You replace it with 4, same thing. And it keeps on going all the way until you replace that I with n, which will still give you c. If anything raised to that 0 power, we'll put that there to show multiplication. Okay. Now, if you plug in each one of these, you have those c's added n times. Added n times. Which is just n times c. Or c times n, whichever way you want to write it. All right. So let's go ahead and prove the second one. Okay, so proof of 2. All right, so we have the sum from I equals 1 to n of I. What that's going to equal is, we're going to replace the I with 1. So that's 1 plus, we're going to replace the I with 2. Then replace the I with 3. Then replace the I with 4. Then replace the I with 5. And we're going to keep on doing that all the way until we get to n minus 2, n minus 1, plus n. Okay, so we're just going to keep on adding that all the way until we get to some value n. Alright, so what we're going to do with this one is we're going to add this to itself, but we're going to flip the sums. So we're going to add the sum from I equals 1 to n of our I, but that's going to equal, instead of 1 plus 2 plus 3 plus 4 plus 5 and working up to n, we're going to move the n to the front of the line. So you have n plus n minus 1 plus n minus 2 plus n minus 3 plus n minus 4 plus all the way to 3 plus 2 plus 1. Okay, so we're just adding the same terms to each other. We're just switching them around. So we're starting with n, then n minus 1, n minus 2, going from there. Okay, so if we add these two together, once we add our two summations, it's just like adding x plus x is going to be 2x. So this is just 2 times the sum from I equals 1 to n of I. Okay, so we just added these two together. Now we add the terms on the right side of the equal sign. Okay, so if you line these up, you get 1 plus n, or n plus 1. Plus n minus 1 plus 2 would just be n plus 1. You have n minus 2 plus 3 would just be n plus 1. N minus 3 plus 4 is just going to be n plus 1. N minus 4 plus 5 is just going to be n plus 1. And that's going to keep on going and going and going. Because if you do the same thing with n minus 2 plus 3, that's going to be n plus 1. N minus 1 plus 2 is going to be n plus 1. And your last one here is just going to be n plus 1. So we know it's just going to be a bunch of n plus 1. Okay. Now, since we're going from 1 to n, we know that we added these n number of times. Okay, so we can actually rewrite this as 2 times the sum I equals 1 to n of I of n times our n minus 1. I mean n plus 1. Sorry about that. Okay. Now, if we divide both sides by 2, these two will cancel out. And we will be left with the sum from I equals 1 to n of I is equal to n times n plus 1 divided by 2. So that's how we came up with our formula for that one. All right. So if you are still writing, feel free to press pause, but we're going to go on to our summation properties. All right, so our first summation property, we have the sum from I equals 1 to n. Let's say you have x of I, either plus or minus, works the same with both. Y sub I. Okay. Now with this one, you can just distribute the summation to both. That's equal to the sum I equals 1 to n of x of I, either plus or minus the sum from I equals 1 to n of y sub I. So you can distribute the summation sign. So if you had 3 terms, you would just distribute it to all 3 terms. Okay, now our second one, we have the sum from I equals 1 to n of c x of I. We can get that constant and bring it out to the front. So you have the c of the summation of I equals 1 to n of x sub I. Okay, whatever this expression happens to be. Okay. Our third one, if you have, let's say, the sum from I equals 1 to n of x sub I plus, this is 2 separate terms here, x sub n plus 1, then that's going to equal the sum from I equals 1 to n plus 1 of x sub I. Let me clean up that I a little bit. Of x sub I. There we go. Okay, and the reason for that is, just to give a quick explanation as to why that's so, if you replace I with 1 here, you'll get x of 1. Replace I with 2, you have x of 2 plus x of 3, and it'll keep on going all the way until you reach x of n. Okay. Now, you're also going to add x of n plus 1. Okay. So that means if you wanted to rewrite this whole thing as a sigma notation, you have the sum. Remember here, let me make that 1 a little smaller so it's a little less confusing. There we go. Well, try to make it a little smaller. All right, so you have the sum from I equals 1 to n plus 1. You can see here that 1 is changing from 1, 2, 3 to n all the way to n plus 1. So you can rewrite it that way. Okay, so you can change your upper bound if you're adding one more term. All right, and last but not least, you have the sum from I equals 1 to n. You can break that down into as many sums as you like. Okay, so if you wanted to make that the sum from I equals 1 to some constant c of x of I plus the sum from I equals c plus 1 to n of x of I. Okay, so for example, let's write the example over here. Because remember, this is the, I guess you could say the proof, and this is just the example here. Okay, so these are your actual properties over here. I don't want you to mix them up with this one. Okay, so let's say if you have the, I got my x of I. Let's say if you have the sum from I equals 1 to n, and instead of n, let's make that, well, we'll leave it as n of x of I. You could break that down to the sum from I equals 1 to 7 of x of I plus the sum from I equals 8 to n of x of I. Okay, so you add the first 7 terms, then you go from the 8th term on up. Or you could write it as the sum from I equals 1 to 20 of x of I plus the sum from I equals 21 to n of x of I. So you can add the first 20 terms and then start at the 21st term and add those. Or you can start at the first 7 terms and add the 8th term on up. You can go with any combination of those values. Okay, so that's how you can separate your summation values, or I guess you could say your summations. All right, so hopefully this made sense. Go ahead and take a breath, and I'll post videos of examples using these properties on our next video. So hopefully this made sense, and I'll see you on the next video.